Okay, hello everyone. My question is, can you hear me? Or if this is working, please say something into the comment section and we're gonna start shortly. Oh, cool. Yes, awesome. I can see you guys saying something in the comment section. Perfect. So, yeah, it seems like there's at least, yeah, 12 people now connected. Yeah, I guess that's gonna be cool. Today, I wanted to discuss something which is all about list manipulation and the most important topic. Um, it's gonna be archived. Don't worry. I think I'll upload it. Maybe we do some minor adjustments if there are some dead spots. But this is gonna be uploaded, so don't worry if you miss something or something like that. Okay, so today it's gonna be about list manipulation and actually like doing stuff with lists. Enjoy my outfit because I'm sick a little bit, just a little bit cold. It's not the thing, but it's funny to be at home coughing and sipping tea. Um, so let's start. I hope you have the file I sent you in that email. If you don't, you can download it on our website. You know the website. I don't have to say that. Um, and I would like to focus your attention here on this little thing. Here's this panel. It has some text in it, and there's another panel. It has also some text in it. And I labeled it that over here the multi-line data is checked. That means this thing, when you right click, is checked. That means this is just text for Grasshopper. And if you uncheck that, it looks like this. Now it's indexed and now it's a list. So this is text, this is list. And if we actually, like this looks like there's some names, it finishes with JSON. But if I uncheck the multi-line data, you're gonna see that there's one more thing in there, and that's named empty. And this could be potentially a source of problems a lot of time. So when you finish typing into your panel, make sure that there is not this enter, like finish typing JSON, you hit enter, and then you realize, oh shit, I have to close this. So you close it, and now there's even one more thing down there. So make sure that there's nothing in there, and that's how a healthy list can be created out of text. So if we move on to this list item, there's like this whole list, and I hope you already know this thing which is called list item. But in case if you don't, this is one of the like most useful components ever. The important thing it does, you just provide it with the index. So see, Gabe is on index 6 and I get exactly that name, and you can scroll with this. That's how it works. And this is very important for like any kind of script. You sometimes need to select just a few things. This is important. And sometimes you want a portion of that list, not just one thing, and that's where you can use our friend series. So I'm gonna start my series at 2. I'm gonna say it has four things in there, so it's like numbers 2, 3, 4, and 5, and you're gonna get names from Cecil all the way to Frodo. So make sure that you don't forget about series, because it's very useful for generating these index index numbers. By the way, I just realized, do you see my mouse or not? Maybe just type into the commands. Yeah, perfect. So that's great. I just got worried that it doesn't work. So thank you. So list item, very important one, and there's another one which is called shift list. I hope you already know it as well. let's check out what shift list does. You know, you have a list, and by providing a shift number over here, which is an integer, you can shift that list around and see that right now we're not starting with Anne and Buck because we shifted in positive direction too, and that means Anne and Buck are now on the end of that list. Very useful thing. Maybe right now it's time to. Oh, okay. Let's check this out. There's another thing. By default, this input for wrap is turned to true, and that's why whatever number you provide, uh, you know, the things which were deleted from the start gets to the end of the list. Sometimes you don't want this, and that's why you click on this thing, and the list gets chopped, or you know, you get just the portion you shift away. And the funny thing is, you can use this with negative numbers. So I'm gonna just double click on the slider here and say that minimum is -10. Hit OK, and now I can actually do shifting from the back. So right now you can see that I got rid of the empty thing, Jason, Ida, and even Herbert by providing -4. So this is also very useful, and I guess right now it's time to make a little example, like something with geometry, so you can check it out as well. I'm gonna freeze this, just disable, I mean, and if you just go to this one example on the top, just enable that. I'm gonna click this to see where it is, and you know, this is like a little truss thing. You know, you can make other links in there, and then it can be you know, a beam with trusses on it. You know, it's just simple one curve, then I move it up, I divide it to some points. I can change the number of points in here, and now I'm using shift list, and check this out. This shift list has number 1 and the wrap is turned off, so this point is not any longer in that list, and this one has shift of -1, and that means the last point is not gonna be there in the list. And then when I make a line from like A and B points, I have diagonals. You can experiment what happens if this is -2, or you know, things like that, but I guess it's quite clear in this simple solution. And if you think about it, we can actually change this very quickly to a hyperboloid generator. So over here, that's the same situation, and the only change is that I started with a circle, another circle, I divide that circle into points, and then I make a shift in +1 and -1 direction. The only difference is I don't want to cut out the last one, because that would actually get rid of the last curve in there. So I'm gonna turn the wrap to true, and I should have this nice hyperbolic surface. I can even loft it for you. Just say loft, ta-da, and maybe we want the closed loft, so in the options I say closed. Okay, so this is how you can make a nice parabolic surface with just using shift list, not any fancy curves or parabolic curves. It's just the way this surface works. So I guess this is cool to know, and it somehow demonstrates that shift lists are important, especially when you have something which is circular, or you know, cyclic curves. So good. Are we all good on this? Is it fine? I think we should continue with something slightly more complicated, and then we get to the nice example with the city. So let me go back to this well, shift list. That's what we did. We have this insert items. I actually thought this one is very useful, but I never used it in my 7 years career. So maybe it's not so useful. Usually, well, you get your lists create it separately, but you can, of course, you can take index 5 where Frodo was and actually replace that, insert the new guy into the list over here, and you can change the index. So that thing on that index is going to be replaced by the new guy, and the list is going to be one item longer. Very cool thing, but to be honest, I rarely use it. Another important thing, really important. There's this list, and sometimes you need to know how many things are there in that list. It's called list length, and you're gonna use it all the time. This one is really important. There's a question. Okay, there's a question from Krista. If we could possibly have the class at the same time, it really would be. And assuming from your name, you're from the English group, so it should have started 10:45, right? Yeah, I believe we can do this. I also wanted to like consult this with the Czech group because they are now listening as well. So maybe we're gonna have email discussion about this after the lesson. But thank you for your question. I think I was thinking about it, but I was kind of lazy, so I wanted to put the two things together. But good question. Let's maybe save it after the course. Cool. So can we continue with the important stuff, and that's dispatch. Everybody ready? Okay, nobody writes, but I will assume that you're ready. Okay, cool. Thanks. So in here, I have this list, and this is a very important concept. So let's try to understand this concept very easily on the names here. And after that, we're going to use it in different contexts. So in here, there's like, the same list, and dispatch asks for any kind of list, and it's dispatch pattern. By default, it's set to 1, 0, or it's the same as if I wrote true and false. In Grasshopper, and actually in Python, and even in C#, I guess, number 1 equals to true, number 0 equals to false. So sometimes you can use it. So if I reconnect this, it's the same thing, nothing gets read, it's working. But sometimes it's even more useful to use the numbers, it's faster to type and so on. So what happens with this list is, check it out. It's like this one is actually working in a different way than all the other things in Grasshopper, because this pattern gets repeated. So n gets 1, and that's why it's true. So that's why she goes into the A output. And then Buck, because he's second, he gets the 0. That means false, and he goes to the B. And this is how you can separate even and odd things, which is very useful. In many cases, this is very useful. I mean, like doing constructions, you want every second piece to be connected to every, I don't know, third thing. So many cases when it's useful, and I think it's important to note that dispatch doesn't work the normal way how Grasshopper components work. Normally, if you have a long list and a short list, what happens is the short list gets repeating the last value in there, right? So normally this dispatch pattern is shorter than this, and that would mean that the number 0 would be repeated, right? But since it's a pattern, and there are a few components which have a pattern in their input name, that means this is gonna be repeated until the end of the list, but in its entirety, not just the last thing. So if we wanted to do some cool pattern, we can actually try true, true, false, true, false, or something like that. And I could done it with numbers. But if I do this, check this out. This list is going to be shorter because there's only two falses, right? And this one is longer because there's three truths. And if you check it out, it's and, so true, true, false. Cecil goes here. True, Dick goes here. And Elizabeth again goes to B because she's on the position of false. So is this clear? Because this is kind of changing the way we thought that components work because it's a pattern. So let's maybe try this in a geometrical context so that we know what's happening and we can see it more clearly than just names. But this is a very handy component. We're going to use it a lot of times. So let's maybe dive into this example, maybe this one first. I think they're both the same, but we're going to see. So I'm going to enable that, and once I have it selected, I'm going to select this, zoom, and this is nice, and I think my graphics can still go to rendered without much lagging. Yeah, it's still almost okay. So in this case, let's look at the script. So I'm just gonna click on this green thing over here, and that means everything I select is gonna be visible. So in the beginning, I have this box, and I have the points. Well, those are not visible because they are overlaid with this preview. So I'm just gonna uncheck this. So I have points, and what I'm doing in here is I'm asking for the x coordinate of them. See, probably should drag it like this. And if the x coordinate is smaller than a number I provide over here, that generates, again, our true, false, 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 true, some kind of pattern. And the thing is, this pattern is already the same length as the number of points because, we generated from the points. So over here, I have 100 points and also 100 true and false statements. So this can filter my points. So those which have x value smaller than 440 end up over here because it's true for them. And those which have something bigger are over here. And what I decided to do is just place the sphere on those which are smaller and a box on those which are bigger. And this is how you can do conditionals and things which can filter your geometry based on some kind of properties and stuff like that. So imagine you have a bunch of curves, and some of them are closed curves, some of them are open curves, and you really want to I don't know, add a little segment to those open curves to actually close all the curves. So you just ask Grasshopper if the curve is closed or open, and that provides you true false. You can filter it, and then you close those which need it, and you don't do anything to these which are already closed. And this is where we get to an important part. In order to have everything working nicely, there's this weave component, and well, some of the names of these inputs are kind of misleading, but if you separate a list into two lists like this over here using the dispatch, when you want to get them back into one list in the same order, you need to use this weave. So it's kind of useful to remember that once you dispatch, you still need to weave the data back together. Sorry. Nice. So once you have a dispatch, you separate into two lists, and then if you want to get the data back in the original order, you need to use the weave component. And the P stands for, well, pattern, and this way it's based on the numbers. So that's coming from here. Remember, true and false are the same things as 0 and 1, and it's kind of flipped over here. So A output from the dispatch is the one which belongs to the true ones, like 1, and it's on top, and down here in weave it's on the bottom. So I always hated this, but well, this component is actually meant to do something else. You can add more. So that's cool feature, but in here you cannot add more, so it's kind of stupid to me. But if you remember that true equals 1, then you probably know that those who were from here should go to this input. So this is a really important concept, and when I just turn this on, we're gonna see some, boxes and circles. And if I move with the slider, the circles disappear. When it's 0, there are no circles. See, there's no data over here, no spheres. And it gets back into this list and nothing is orange anymore, but there's just nothing in this branch. And if I go the other way, I could get to an extreme situation where there's no cubes, and again everything gets back into the right order over here, and this is where you get your data. You can preview it nicely. So I hope this little example is helpful to understand what is needed when we do data dispatching, or conditions. Like, is something bigger or smaller, or is something equal to something, and stuff like that. Because this concept is huge. It's actually, the basic of all programming is conditionals. And sometimes there's no other way than just, ask Grasshopper, like, are all these panels bigger than something? The area is bigger than something? And if yes, we have to maybe subdivide them because they are too big or something like that. And then you need to get the data back into the right order using beef component. So this was just a quick go through, and I guess it's time to jump into a new file and test this in some more complicated context. Are you ready for that? I'm still waiting for somebody to write a thing. Okay, so there's some other things in this file, but we're gonna jump into that maybe later. Okay, thank you, Baro. I'm just gonna disable this, and I'm gonna try to switch to a different file here, and I hope this window stays on. So if something happens, just let me know. So I'm just gonna go to attractor file, and is it there? I hope it is. Yes, perfect. So this is a file you don't have, and this is where I want us to finish today. So I'm just gonna show you quickly, and then we're gonna try to together to get there. It's a nice, like, huge city where there's a river, and everything which is next to the river gets really organized, and it's really like a grid like thing. And then on the outskirts of the city we get more random behavior, and it's based on distance. So the further away from the river, the more crazy the randomness gets, and you get small houses and something like that. Of course, I don't mean this literally, but it's a principle, and I believe it's a good testing place to really try these conditions. So in order to make this work, we're gonna need to remember. Oh, wait. Yeah. We're gonna need to remember this thing. It's remap. And that's an important thing. I hope you remember this from last time. We're gonna use it multiple times, as you can see. It's actually 4 times or even 5 times in the script. So this is a proof to you that remapping is important. Okay, so let's quickly jump into a new file, and let's try to do this. So Control N. I hope the window didn't disappear. Yeah, there we go. So I'm gonna start with a square grid. So this is my square grid. I'm gonna say that I want, let's keep it to 1 meter, meters. That's fine. I'm gonna say 20 times 20. Maybe we're gonna lower it later, but let's start with something nice. So let's see that over here. Pretty nice. And you know, it's again something using attractor. So we're not interested in the cell outlines over here. We're interested in the points. So what I'm gonna do again is I'm gonna just put a point container in here, and oh yeah, you're missing the bifocals. It's called square for square grid. You can find it in here in the vector tab grid over here. Good question, thank you. Okay, so now we can see the points. That's useful. But you can see this dashed cable, and that's something we're gonna discuss next week. So I don't want to get all tangled in data tree right now. Just for those who are interested, there's a component called param viewer, and you can see that there's a lot of data separated in different branches. You can see that there's branch called 000, there's 21 points and so on. When you double click it, you're gonna see the structure of the data like this. So that's cool. If you're interested in this, there's a chapter in the book about designing with data tree, so definitely read it till next time. But for today, I'm gonna just go here, right click and say flatten. And you're gonna see that now there's just one branch of data with all 441 points, and that's all we need. So just points in one big pile of data, actually one big list. So this is a list we're gonna use today. So make sure that this is there. I think we done something like this last time, and a lot of you forgot to do this, and then everybody was like, hey, it's not working. Just make sure that you flatten the data. Okay, so we have points, and I think it's time to create a curve. So I'm just gonna jump into Rhino, select this curve. You can, if you don't see this button, you can actually just type underscore curve. It's the same command. Let's keep the degree at 3, and I'm gonna just make some nice wavy curve like this, going through the point area, something like this. So I have a curve, and I need to reference this. So I'm gonna type curve, right click on that, and set one curve. Wow, cool. There we go. Yeah, Grasshopper disappears when you do it, so it's funny, but now we have this curve. And this curve is gonna be our attractor. So I'm just gonna label it here. For those who missed the previous class, this is another core concept, so make sure that you get fluent with this. So this curve is gonna be making the important places in our city. So I have this curve, and I'm gonna ask for curve closest points, and everything with the closest point has a shortcut of CP. So I just type CP, and there we go. There's this curve closest point. Oh, you don't see that. I just realized you don't see my search box. Okay, sorry about that. But it's curve closest point. It asks for some points. Okay, so that's our points over here, the reactor, right? And the curve is gonna go from here. So right now I have this points on that curve. They're actually all pulled towards that curve in a perpendicular way. And in order to see that, maybe it would be nice to put a line into there just for visual reference using these points. So now you can see what's actually happening. Like over here, there's a special place where these points have it closer over here. All the other points are just being pulled perpendicularly to that curve. And we're actually not interested in this line. We're interested in the distance, and that's actually similar to things we did with the point attractor, right? We just ask for a distance, so it's not so much different than the other attractor cases. So we're gonna use this distance to, you know, do something. And let's do a very quick thing with this so that we can visually see what's happening right away, and then we're gonna start improving this example so that it looks nice like the finished file. So let's put a box. I'm gonna use the domain box, and let's put this box onto the points. So these points are gonna be XY planes over here, and I'm just gonna use these planes for these boxes. And the only thing is the X and Y, I'm just gonna make it normal, like one number for now. We're gonna change this later. So I'm gonna say 0.5 meter. And now the thing is, if you stop your mouse over the X, Y and Z, you're gonna see that this should be a domain. So if I plug the number in there, it's gonna be from 0 to 0.5. Well, it kind of looks okay, but you can see that it's drawn from this plane, like from the center of it. Kind of makes sense in some cases, but usually what I want to do is create a domain. So I'm gonna make a construct domain, and I'm gonna use this number to be the maximum, and I'm gonna use negative components to make minimum for that as well. So I just need some more space. So when I do it like this, they're gonna be all nicely evenly spaced out, and I can lower this to make some space in between. This is actually a very common thing, so I really want to show you this. Sorry. Okay, so we have some boxes. If you have any problems, try to type it into the commands. It's possible that someone else is struggling with the same thing, so make sure that you're up to date. Okay, so I have this. It's boxes, and the Z coordinate should be maybe from 0 to, well, you know, we can use this number. So I'm just gonna make a construct domain again. Construct domain for the Z, and I'm gonna say the minimum should be 0. That's fine. The buildings don't go below 0. That's fine. And the maximum is our important number. Maybe before I do that, I'm gonna just do a little separation here. I'm gonna say that this is a number, well, obvious, ta-da, but it's the, you know, that's the important number. So I'm gonna say important numbers. Yeah, this is what we're working with. So when I plug this into Z, I have this crazy city happening. Well, it's already looking pretty nice, but there's some problem. When we are close to the, you know, the attractor of the city, the river in this case, we're small, like almost super small, and very far away from the important place in that city, the river, we're high. So this is not the case we want. So what do? Any ideas? Because we've done this last time. How to flip this? How to make it the opposite? Well, nobody's typing. Some kind of inverse. Uh, okay, I'm gonna try typing inverse. Yeah, that's not gonna help you. Remap, much better. Thank you. So remap, and since you created those plugins, I mean the snippets at school, so I cannot use this remap snippet. But remember what we done. I can just get this created in, like um, using this plugin called MetaHopper. So maybe download this for next class. But I'm just gonna do it from scratch so that we all can follow. So I always start a remap with the numbers again. So this is redundant, but it's a good habit. I put in the remap, and the values to be remapped are these. And there's two domain inputs. This is for the source, and this is for the target domain. And the source domain is something we have to figure out from all these numbers. So these numbers over here can range from 0 to, I don't know, 50 or something. And in order to calculate the domain, we have a component called bounds. So this is the one which is going to calculate our source domain. And then the target domain is, again, a construct domain. We can just grab this one maybe and provide it with two sliders. So I'm gonna say that maximum is like, I don't know, 20 meters, and the minimum is maybe, well, I'm gonna use the same slider and we're gonna fine tune the values. So right now these important numbers over here get remapped into some usable numbers, and we're gonna say that the maximum is lower than the minimum, and then when I use these numbers in here, it flips the behavior. Right now would be a nice moment for some questions if there are any, because this is the key thing about attractors. If there are none, we can continue. So this is what makes our city high when the buildings are close to the river, but we still need to do something with the with the randomness and probably even with the position, right? Remember, it looked totally different. So I'm just gonna take all of the things I just created, maybe make some groups over here. This is just the final okay, I mean this might be another group. Remapping is just something over here. Perfect. And this is what I'm using just for the height, so we can keep it. So maybe this also can go over here. So right now it's time to do something with the position, because it's all like square grid and it's kind of boring, right? And in order to like have some places which have the order of the grid and some places which are totally random, we have to make some kind of dispatch again to say that some points are gonna stay on the grid and some points are gonna be shuffled. So I'm just gonna move these two things away so that we have space in between. And in this case, I'm gonna need to ask the distance if it's higher than or smaller than something, because we remap it here, but let's think about these numbers as distance. So I'm gonna ask if they are smaller than some kind of number. I'm gonna say 12.56 or something like that. And I'm gonna get a list of trues and falses, right? So here's some are true, some are false. Yeah, there's a lot of true, maybe some other false. Yeah, okay. I'm gonna lower this. Yeah, this seems better. So maybe the maximum should be not 100, but maybe 12, something. Oh, did you hear that? Sorry about that. I think I'm gonna I'm gonna disable this system sounds next time. Okay, so we have some true and false, and we need the dispatch. So I'm just gonna take this dispatch, I'm gonna feed it the pattern, but this time I'm not interested in the list of numbers to be dispatched that much. I'm actually interested in the points, or I can be actually interested in these lines because we can convert them to vectors. So what I'm gonna do is I'm gonna dispatch the points because points are clearly visible, and this is a thing I don't like about dispatch. When I click on this, I would assume that I would see just the A output, and the B is the one which have false. So I don't wanna see them, but it actually shows all of them. So in order to have a preview what we just selected, it's always good to put some points containers after the remap. So now we see that we selected just these points which are close to the curve like this, and these points which are too far away from that. So make sure that you also see two different groups of points. And once we have this, we can actually, we can actually start doing something to those two groups of points. So our script actually branches in here into two, and those who are too close, like this, those are not gonna move at all. So we can just keep them like they are. But those who are far away should have some randomness around them. So what I'm gonna do right now is I'm gonna just take random number, create a vector out of this, and I'm gonna randomly move these things. Just one little thing, maybe it's gonna be useful to use the direction towards the curve because it looks a little bit nicer. So what I'm gonna do instead of these lines here, oh, okay, maybe let's start with the randomness first. Let's do pure randomness, and then we can try to improve this. So these points need to move randomly. So I just create random number, and this is a new component. So let's look at it. What does it want? So range is a domain of where the numbers belong to. So from 0 to 1, kind of good. But in this case, I want from -1. So I'm gonna just exactly type it, -1, capital T-O +1. So this is gonna be my range. I want the points to be able to move forward and backward, both. So not only from 0 to 1. Just -1 to 1. How many numbers do we need? And this is the seed. So how many numbers we need? Well, exactly one number for each point over here, right? So how do we get how many points I have got over here? If you stop your mouse over there, you should see that, like in this case, I have 276. Any ideas? How do we get this number into this inputs over here? I'm just gonna wait a little bit. No ideas? This is a very common thing you're gonna need to do many times. I have many points here, but it's different amount of points than in the beginning, right? So how do I calculate how many things are there in my list? Maybe if I just use this panel over here. If I scroll down, I need this number, 275. And this can change, right? Because when I slide with the slider, it's 321. And when I increase this, list length, thank you, thank you. Perfect. So I'm just gonna delete this and I'm gonna use list length. So here we go. And now I have this number 166 in this case. So now I should have 166 random numbers for the x of that movement vector. And I'm gonna duplicate this thing for the y. Z is gonna stay 0 because we don't want to, you know, get cluttered in there. So I'm just gonna make this a little bit tidy. Okay. So I have this list length. I have a random vector now. If we want to see this, let's use vector display. So this is the vector and these are the anchor points. And you can see that, you know, they all seem to be in one direction, and that's because my seeds are the same. So I'm gonna just provide this seed a different number, and now it's all random vectors. In order to be able to change both, it's actually sometimes useful to have a different number in here. So I'm just gonna use addition to change the second seed. I'm gonna just place the different slider. This slider shouldn't be 0, and now we're done. So now I'm sure that there's always gonna be a different number in here and in here in the seed. That means my vectors are always gonna be, you know, random. So I can slide with this and see some changes, and this is also changing. Yeah. So we're gonna use these vectors to move the points. So right now the vectors are almost 1 unit long maximum, which is not much, but we're gonna see some movement, so that's good. So I'm just gonna say move. So these points should move. Okay, so these points should move using these vectors. See, it made some noise in there. And well, now I'm in the problem that if I connect this over here, I want to see my boxes. I'm gonna lose all those boxes which were, you know, in the middle, right? The ones we filtered out, and it seems like my order is jumbled, so it doesn't work. So remember, there are also these points. So we need to use the weave to get the two things back into proper order. So the weave needs the pattern, and that's over here, remember, the true and false pattern. And those which were in the A output, I'm just gonna A equals 1, sorry, equals 1 equals true, right? So I'm gonna place these points into 1, and these points which are changed from over here, those are gonna land into 0. And now I can put it in here, and you can start to see some randomness. Maybe I'm gonna lower the area next to the river, and this looks better. Oh, this component with the random this thing, I just double click and type 2 slashes. So I'm gonna make a new one and I'm gonna type it into there. So if you start with these two things in the search box, that's gonna give you an opportunity to write anything in there. So I'm just gonna type anything in here and hit enter. So you first need to have these 2 slashes, and then you can have a panel with everything in there. Very cool for setting up some hardwired numbers and you know, we're not gonna change this. It shouldn't be a slider, so that's why I'm putting it into a panel. Okay, so that was for Matouš. So do you have something like this? Some area where it's random and some area where it's totally square grid? How did you get the... Yeah, I just said how to do that, but Sophie, once more. Of course, you can create a construct domain. Yeah, okay, I'm just gonna type it again. -1, 2, 1. The thing you have to type into the... Yeah, okay, I'm gonna finish with this. Just double click and type this into the panel and you're gonna have this. The 2 slashes in the beginning means it should be a panel. This should be the solution to that. And back to the weave. If I zoom out like this, you know, this is where I get my dispatch pattern. And I'm separating the list into these points and these points. And the weave gets the same pattern, and those which were in the B output, meaning the B is equal to 0 and that's equal to false, right? So those which came from the B have to go to the 0 input, and those which came from the A have to go to the 1 input. So this is how you make the weave work to put the data back into the proper order. If you're not sure that your order is intact, we can use list item. And this is a cool approach I do all the time. Like when I'm not sure about my data, I'm actually gonna, like, you know, these are points. So we can check them from below. And I can provide like a slider which is gonna go from 0 all the way to 441. That's how much points I've got, right? And I just select this and I move with the slider, and you can see that it goes through that list in a really organized way. That's how my data was organized. So if you're not sure about that, I always use list item and see the first few with a slider. We can actually do the same thing with the box. So now I'm selecting the boxes, and you can see that even though some of them are randomly moved a little bit, they are all organized according to the grid in the beginning. Okay. So we're missing one little thing right now, but otherwise we're almost at the, we're almost there. So the problem is that right now the randomization, you know, it happens just like suddenly, right? Maybe if I make this a little bit shorter so that we can see it better. And I'm gonna hide all those lines and maybe even this, you know, clean it up a little bit. I don't need to see the points on that curve, right? We know that they are. So this is it. And maybe even the vectors are not important right now that much. So, and the original points. Okay, I'm gonna hide all of this. Okay, and the original points also not needed. So I just have a lot of boxes, and this seems like, you know, the randomization happens just right at this area, right? It's too fast, and we can do something about it to make it start a little bit slowly, and then start to happening like proper randomness. Like over here, maximum randomness because it's far away, and well, over here it's just very close to that curve, so not that much randomness. And that's something we can do with these numbers. Where exactly do you want me to zoom, Sophie? Like maybe this part, right? Okay, so let's get back to the issue that the randomness starts too fast. If it's too fast, that means we are randomizing everything in the same way. So these random numbers are just random numbers, and that's not useful. We want to randomize some of them a little bit and some of them a lot. And that's something which can again be achieved with the our important numbers, because remember, if this number is big, that means it's far away, and in this case we don't even have to use the remap for that, because we just want wherever is far away, we want a lot of randomness. So this is another core concept. If you have some vectors like this, I'm gonna make them visible again. Right now they are all kind of small. Some of them are bigger, some of them are smaller. It's random. But if we just multiply these vectors uh, by the numbers we get from the important numbers, we're gonna get much more interesting transition from the grid to the randomness. But the problem is these are numbers for all of them, right? It's 441, and in here we have just 349 vectors. So what happens, and it's quite often, is that you have to dispatch something like maybe the points to move and not move at all. And also you need to dispatch the numbers. So I'm gonna make another dispatch here. And this dispatch is not gonna be filtering our points, but it's gonna be filtering our numbers. See? So if this number is smaller than 2 point something, we're just gonna have it in A. If it's bigger, it's in B. And that means in B, I should have this 349 values. And I can use these numbers to multiply the vectors. Let me quickly show you how does it work, how does it look. And we're gonna see a lot of randomness in here, right? The vectors gone just crazy. And the fact is, well, these numbers, which are coming from here, are usually bigger than 1, right? So 5 or something, like, these numbers are pretty, like even 10 and 11, like that's huge. So if you multiply something by, I don't know, this much, it gets too big. And, even the randomness is like from -1 to 1. So we need to remap this in order to have, proper movement. So these numbers over here cannot be just multiplied. We have to remap them as well. So again, let's do the remap routine. I'm going to repeat it once more. Number. I want to remap these numbers. I'm going to take remap. So these are the values I want to remap. And I want the smallest of them to be 0. Because, that means even the one which is already behind the edge is not going to move at all. But then the transition is going to be smooth. I hope this makes sense to you. So let's try to build this. Bounds. Again, to get the source values, right? So that's that. And construct domain. And I'm going to say that minimum is, I'm going to say default layer, the minimum is 0. Like this, strictly. So the closest random points are actually still not going to move. But the maximum is, let's say, 5 maybe. And that is going to say that the point which is further from the furthest from the river. I mean this one. This one is allowed to move 5 meters away. So that's gonna be a lot of movement. So I'm gonna just put it in and see the vectors are pretty calm over here and they get crazy on the outskirts. That's okay, we don't care about intersection right now. So we can use these new vectors in here and see, like maybe 5 is too much, but now we get a nicer transition from the proper grid to the outskirts. So I think 5 is really too much. So I'm gonna say 2. Yeah. So you can see that the regular part of the city just got a little bit bigger, but you can see some minor irregularities already, and then it gets totally crazy. And you can have as many versions as you want by just sliding with this random value slider, right? So again, this is a group which is important. That's again the remap, which gives us more control over the vectors. And I believe this might be almost the whole thing. So I think right now it's time to give it some colors and to start answering questions. So maybe like, do you know how to give it colors? Or should I show it? I think, yeah. So like this part gets a little bit extreme, so I try to clean it up a little bit. So this is the random vectors. Okay, I think I'm gonna show the colors anyway. I'm just gonna give it some space here. This is the weave, and this needs a little bit more attention here. So when your script gets a little bit crowded, like this one is getting, I suggest, like in this case, we know that these are the important numbers. So you can right click the input and change the wire display to hidden. And it's gonna be visible only when you click on that. That's very useful. So it's not crowding up this place. Also maybe for the attractor, this is not important connection, so I'm gonna make it. Yeah, so I can see some questions. Cool. How's the A, B, and R? A, B, and R. You mean this? It's multiplication. Perfect. Yeah, it's the icon says multiplication. Okay, so now it's a little bit clearer to see what's going on in here, right? We first generate some random vectors, and then we multiply those random vectors with some values which we separated from the initial important numbers, right? Just the B output, because we want to have the same amount of data in here and in here. So yeah. Maybe I can clean this up a little bit. This goes here as a hint. I can actually do a little bit of this. Yeah. Well, it could be cleaner, but I hope it's better now. Okay. So let's do the colors then. Any other questions before we do the colors? This file is going to be uploaded to the website as well. So if you have some trouble with your own script, or if you want to clean it up, you're going to have chance to see this as well. So that's going to be cool. if there are no questions right now, let's do the colors then. Okay. So we're gonna color these boxes. Um, that's another part of the script. We need the gradient, remember? I'm gonna right click on that and I'm gonna select some presets. I kind of like this preset with the red color and blue color because it's like, you know, in the weather, like red means a lot, blue means kind of calm. The only problem is it's actually, you know, it's the red is here on the left side. And that means red is going to be labeled to the low colors and blue is going to be for the high colors. So again, this is a case for a remap, right? But let's first build the initial thing, and we're gonna see what to do. So custom preview. This is gonna be the material for it, and the G, of course. Those are the boxes. And right now it's not working because this gradient thing just needs numbers in the T from us. So this should be the lowest number in T input over here, and this should be the highest T in this input. So, well, there's two ways how to do it. There's the relative and there's the absolute. And in this case, like, you know, I'm gonna keep it absolute, but those relative coloring are more useful when we do simulations. So we're gonna touch on that with Kangaroo later on. So let's do this absolute. So there's definitely gonna be one red box, and that's gonna be maybe the one who is definitely the closest to the river, and there's gonna be one blue thing which is gonna be over here, and we're just gonna have all the colors from the gradient on our geometry. So I'm gonna go to my important numbers all the way up here, and I'm just gonna do this trick that I connect something important like the important numbers. Again, right click, and via the display, maybe faint, slightly less visible so that it doesn't crowd up my script. And I'm just gonna put it in here, and you're gonna see what does it do. So if it's there, it looks like this. So, you know, remember these numbers, they go, of course they have the low values in there, right? There's low values somewhere, but most of them are pretty huge. So let me search for a place where it's like, yeah, there's even 1 point something. So, you know, there's small values, but that's only for a few boxes, and the rest is bluish, right? So that's not how we want it. So again, we can remap this thing, or we can actually make use of these two inputs, because this is for L0, like the lower limit, like actually this red number, and the L1 is for the blue number. Excuse me. So what we're gonna do is, again, we're gonna do bounds, our trustworthy friend, and then we can do deconstruct domain to get the minimum and the maximum out of the numbers right away. So if I do this, then we have a proper coloring of those things. And of course, we can actually even like do some changes to this to make the blue part, the blue area, slightly bigger. You can have some discussion where does a city end or something like that. But yeah, well, not but this is it. And in order to make everything nice, you can see the corners of everything. I always uncheck the preview of like everything except the custom preview, and then well, it's time to switch to the rendered and see something nice, probably. Ho ho. Yeah, perfect. Welcome to Rhino 6. It doesn't do rendered now. Maybe that's all the testing I did before, but yeah, it should work, but sometimes it does not. Make sure, yeah. Okay, so I think it's time for questions now, and you can still grab that curve, hit F10 to get its points, and you can just play with the points of that curve. So I'm just gonna drag this over here, and you're gonna see a different situation. I'm just gonna grab it over here. You know, just play with it, give it some other colors, and that should be some images on your blog. I'm sorry. My question is, what about the audio quality? Is it can you hear me clearly, or is it noisy? Okay, thank you. Yeah, great. That's good. That's good. Pretty clear. Actually, I have two audio interfaces and both of them failed. So that's good that the internal speaker is fine. Make sure that you really understand this dispatch and weave relationship. That's actually the bottom line of this, and we're gonna continue with the list and other things next week. In the meantime, I guess you can use my email to write me. We can discuss those the timing maybe, and yeah, maybe. Are there any questions to the topic of like separating values and treating some of them differently than others? Because this is important topic. And really, if you see some place for improvement, tell me maybe in the email later. Because well, you know, this is the first stream I've done, so. Maybe like since you are still there, maybe a question to the Czech students. Are you okay with this being in English from 10:45, or do you really want me to do the streaming 2 times, and one in Czech and one in English? It's just like you have a right to ask for that. So it's just, if it's better for you, I'm gonna do it. If it's not necessary, I think it's then not needed. That's the thing. No problemo. Okay. Yeah. Other ideas? Okay. Do you like the outfit? It's, you know, from Winnie the Pooh. Cool. Okay, so I'm gonna stay here for a few minutes, but I guess this is all for it. Maybe we should have okay. Yeah. So about the time, I can see that might be a problem, because some people might be having something happening from 10:45. Um, okay, we're gonna see about that. Just I think I'm gonna use the website again for placing another video in there next week. So That could be, yeah, that could be still working. Okay, 10 is better than 1045. Yes, Sophie, please still maintain your blogs, because well, this is gonna be your attendance. Like, I really need some data whether you did something or not. So make sure you have some pictures on your blog. Um, Make sure to improve this somehow, like give it some nice colors or use the rendered stuff. Or actually, there's a question. If you look at this example we have over here, and if I switch to the older file, there's a slight difference in something. See? Maybe it's in the curvature of how quickly it rises. See that? So that's a question to you, how to make it work like that. And if somebody has this on blog done properly, that means you've understood the previous lesson. So that's good, and I will be really glad if someone of you try to figure it out. So if you look at this, we can see that the slope is almost linear, right? But remember, in the other file, the slope of growth is not linear. Maybe some other part, yeah. Like over here, you can see it grows like some kind of curve. But in the previous file, come on, yeah, in this file it's just flat. So try to figure this out and put it on your blogs. Those who do will have some plus points for the final grade. I think I'm gonna do a question like this after every single class, because I really want you to, like, you have a lot of time right now, right? So I want you to really dig in and take this as an opportunity to learn this properly. Okay. Like, to me right now it seems that 10 o'clock is okay for all of you. Let's now agree on 10 o'clock. If you're okay with that, all of you. Let's say 10 o'clock is okay, and if you have some trouble with 10 o'clock next week, just send me an email and we're gonna make some adjustments, but I would keep it on 10 o'clock. And it's gonna be taking like, yeah, an hour and a half or something like that. Any questions to this? Again, send me email. I'm gonna upload this exact file you've seen to the website so that you can, check some things. And please try to read the chapter about data tree before the next class. Data tree is something which separates pro users from the beginners. And that's why we're gonna talk about it next time, because it's important. And we're not gonna be afraid of this happening again. So if I just uncheck this, maybe it's gonna even freeze. I'm gonna first save my file. Okay, so just a quick quick test. If this fails, maybe the stream goes down, but I'm gonna show you that if I unflatten this, everything is different, and actually it's not doing the things we wanted, because now this data structure is totally different and every single component works in a different way. So this is something we need to know about, because it can actually be a deal breaker. So grab that book I referenced a million times on our website and scroll to the chapter called Designing with Data Trees. and really try to read the important parts of that chapter, maybe check out that file which is included. It's gonna be so much easier to do the next class with that in mind. Okay. So, any other questions? Otherwise, we're finished for today. Do you like this? Can you see some potential use for that? That's my questions. What about yours? Oh, cool. Thank you. um, what do you mean by the curvature? I'm kind of confused. Okay. Like, since there was only 14 people today, I was kind of oh yeah, the curvature. Yeah, the homework. Yeah, I get it. Sorry. Um, yeah, that's actually, it's not about curvature, right? That's why it confused me. It's about the numbers. You have to do something with the numbers, not it's not curves and curvature, but cool tip. I had this one idea. Since it's only a few of us, like 14 people watching, I was gonna think if there is a way to test something like a TeamSpeak or Twitch or something where you can have audio as well. Do you think it would be beneficial? Do you think it would be better than just typing questions? Because I can imagine like jumping out of Grasshopper to your script, like Discord. Okay, so I might check it out because I don't know it. So maybe so Discord is something like a Skype, or it's like a live chat, or how does it work? Maybe send me some link. I'm gonna check it out till next time. Okay. So this is me trying to figure out some better ways so that you can give me some feedback, so that I'm not just talking to my computer here. But yeah, I'm gonna check out that Discord thing. Okay. It works on YouTube because you save the lives. Yeah, this is gonna be there on my channel. So I think I won't cut it because it doesn't make sense. But maybe later on I can make some nice videos out of this. The lives are gonna be saved there, and you can always rewatch that. So okay, we can keep it here. I guess it's fine. The only thing I wanted to try, only other thing I wanted to try is to try drawing. So I'm just gonna take my pencil. So if I want to explain something and I do this, can you see that? Perfect. So when I go back with this, we're back to Grasshopper, I hope. Okay, good. Okay, so that's it maybe. Again, if you still have some comments, please send me some email. And this is it for today. Cool. Try to model something with Grasshopper if you didn't. That's always fun. Okay, see you next time. Bye, guys. Or what, I should do something like YouTube, like, yeah, what's up, YouTube? Bye. Okay. Where do I stop this? Ah, over here. Okay, this is it. Goodbye.